Today we looked at MCAS questions that also have to do with using Pythagorean theorem, special triangles, and trigonometric ratios to solve triangles. So the first question that we did in class today was this one here. It says, the diagram below shows the placement of two support wires for an antenna tower and some of the dimensions and angle measures resulting from their placement. So let's see. We have antenna tower here, and then the support wires are here and here. So it looks like we have two triangles resulting from an antenna tower. Okay, easy enough. So remember, if you have two triangles, you isolate one, solve it, and then solve the other one. So let's start with this triangle here. They give us 30 up here, and that is our clue. If we have 30 up there and this is 90, we know that this angle has got to be 60. The side across from 60 in a special triangle is always y, square root of 3. The side across from 30 is y, and the side across from 90 is 2y. So here they give us y equals 16. We substitute this in for each side. This becomes 16 square root of 3. This becomes 2 times 16, which becomes 32. Okay, easy enough. That triangle is finished. Let's solve this one over here. They give us 90 here, 30 here. We know this is going to be a special triangle. Across from 60, we have 12 equals y square root of 3. Across from 30, we have y. Across from 90, we have 2y. We look for the number in the figure, and that becomes our equation. So we get 12 equals y square root of 3. Solve. Y equals 4 times the square root of 3. We plug that back into the picture. We get 4 square root of 3 here, and we get 2 times 4 square root of 3 here. Equals 8 square root of 3. So see, we completely solved the triangle, and then we go down here and look at the questions. So down here it says, A, what is the measure in degrees of angle E? Angle E is 60 degrees because the degrees in a triangle equal 180, and we have, they give us 30, 90, and x. What is the length in feet of EF? EF here is 32 feet, and we can just write C figure. What is the length in feet of FG? The length in feet of FG. FG is here, and we found that to be 16 times the square root of 3, and we can say C figure. The length of QR is here, and we found that to be 8 square root of 3, and we say C figure. In the next question, they give us two triangles again. So let's do the same way we did in the last problem, where we solved one triangle first, then we solve the other. So we have a triangle here, and they tell us, we have a triangle here. They tell us the angle T is 30, this here is 90, so we know that this one up here has got to be 60. So the side across from 30, we call that y. Side across from 60 is y square root of 3, and the side across from 90 is 2y. We look for the number. This becomes our equation. 8 equals 2y, divided by 2, divided by 2, 8. We get 4 equals y. Substitute that back into the figure. We get 4 square root of 3 for this side here. We get y equals 4. Oh, that's really messy. So the triangle on the left is finished. Let's solve the triangle on the right. They give us this triangle here. They tell us this angle here is 45. This angle here is 45. So this angle here must be 45. So we know that this side here is x, this side here equals x, which also equals 4. We found that earlier. And this side is x square root of 2. So we found here that x is 4, so this side here equals 4, this side here equals 4 square root of 2. So now, after we have solved the triangle, we look at the questions below. A says, what is the degree measure of angle TPR? So angle TPR is 60 degrees. And we found that because we know that the angles in a triangle add up to 180 degrees, and they give us 30, and they give us 90 when we start, and we solved for x. B, what is the length in inches of PR? PR is here. And we know that PR was y, x, and 4, so it equals 4. PR equals 4 inches. See the figure. See how useful it is when you draw a nice figure? You can just reference the figure as your explanation. You don't need to write out whole sentences. Part C, what is the length in inches of TR? TR is this one here. TR equals 4 square root of 3 inches. And our explanation is C figure. Part D says, what is the length in inches of PQ? Up here we have PQ here. PQ is 4 square root of 2 inches. And you see the figure above. So in this problem here, they give us a very complicated drawing. They show us all these things. So we want to make it easier for ourselves, right? Let's split this into two things that we know how to solve. We have one big right triangle here, right? So let's draw this over here. We'll separate it. Ooh. Why did it do that? We'll separate it, right? This vertex is D, C, and B. This here is 90 degrees. They give us this side here is 85 plus 110. So that's going to be 195 feet. And then this angle here, they tell us the line of sight here is always going to be 90 degrees. So then if we move backwards from 90 degrees, 33 degrees, we'll get this angle here, which is 57. So we get 57 degrees here. Well, that doesn't look very good. We get 57 degrees here. And that's all the information they give us for that triangle. So let's look at the second triangle. The second triangle that we'll be working with is this smaller one here. So it's still 90 here. Let's draw this smaller triangle down here. We have vertex D here, A here, C here. This side is still 195 feet. And this angle here, we start at the line of sight, which is 90, and we move backwards 57 degrees, making this 33 degrees. Okay, so now we have two easy to solve triangles. Here we have one side and one angle that's not a special angle. So we're going to use SOHCAHTOA to solve. Okay, so we take the reference angle and we name our sides. This one here will be opposite. This is always the hypotenuse, and this will be the adjacent side. Here they give us, this is the distance we're looking for. We want to find this whole distance here. Let's call that x. And then they give us this one here is 195. So we have the opposite side and the adjacent side. Opposite and adjacent here. TOA, so we're going to use tangent. So the tangent of 57 equals opposite over adjacent. So the tangent of 57 equals x over 195. I solve for x, I get 195 times the tangent of 57, which gives me 300.3 feet. So I put that as my distance down here. Ooh. So now I'm going to use the smaller triangle to find this distance here. So I go down to this triangle, right? And I name my sides according to the reference angle. So this side will be the opposite. This is the hypotenuse, and this will be the adjacent side. I'm looking for this distance here, so I look at the sides that they give me, A here, O here. I write out my acronym. I find OA here. I'm going to use tangent. So the tangent of 33 equals opposite over adjacent. So now I get tangent of 33 equals opposite is x, adjacent is 195. I solve, and I get 195 times the tangent of 33 equals x, which is 126.6. So now I get this length here is 126.6 feet. So I can subtract the two distances that I have in order to get this distance here that I need. And I get 300.3 minus 126.6 feet equals 173.8. So this distance here is 173.8 feet.